Welcome back to our 6-part series where we'll be going over the AP Calculus AB FRQs from 2021. This is the third video in the series, and this will be a no-calc question. If you haven't checked out videos 1 and 2 already, I recommend you take a look at those as well, and I'll provide a link to that in the description. With that out of the way, let's get into it. So here's problem number 3. Just like in the last videos, I will provide a link to this problem as well as the solution guide in the description. And right now I just advise that you pause the video and take a moment just to look over these problems and give your best shot at them. Once you've done that, you can come back and we can go over part A together. Okay, so hopefully those first few problems weren't too difficult. So let's jump into it. A company designs spinning toys using the family of functions and this equation, where c is a positive constant. The figure above shows the region in the first quadrant bounded by the x-axis and the graph of, once again, this equation for some c. Each spinning toy is in the shape of the solid generated when such a region is revolved about the x-axis. Both x and y are measured in inches. And part A asks us to find the area of the region in the first quadrant bounded by the x-axis and, once again, this equation for c equals 6. So right here, it's not even dealing with the volume. Right now, we're just asked to find what this area is for when c equals 6. So what I'm going to do is, we know that we can find the area under the curve using the integral. So right here, I'm going to write a equals the integral. And right now, we don't know our lower and upper bounds yet, and I'm just going to leave that blank for now. And what we're going to write inside is going to be this equation for when c equals 6, because that's the graph that we're working with. So if we write that in, 6x root 4 minus x squared dx. So now that we've done that, we need to find our lower and upper bounds. So over here on the right, I'm going to set up another equation. And this is to find where these x values are. And in order to do that, we need to set the equation, this equation in particular, equal to 0. So 0 equals cx root 4 minus x squared. And you might be wondering, well, why didn't we just plug in this 6 value for our c? Well, we could have, but if we work this out, right, since we have two terms that are being multiplied together and they both have x in them, we can use them, we can solve for x by setting them equal to 0. So 0 equals cx, and we get that our first value is just going to equal 0 for whatever c is, right? So x is always going to equal 0, and the same thing if we set 0 equal to 4 minus x squared, and do the math for this, 4 minus x squared, add x squared to both sides, x is going to be 2. So here we have 2 and 0 as our upper and lower bounds. And notice that our 0 and 2 is going to apply for whatever c is. So whatever c is, these 0 and 2 values are never going to change. So I'm going to write that here, 0 and 2, and also up here just for clarity. And now that we have that, what we need to do now is just solve for what a is. Here's half the problem. We've already earned 1 point. So now we're going to solve for a. And the way to do that, I'm going to rewrite this as the integral from 0 to 2, 6x 4 minus x squared to the 1/2 power dx. And right here I can see that we have a u value, and our u prime is going to equal negative 2x, right? So in order to get this 6x to a negative 2x, I'm going to multiply this by negative 1/3. That way, this times this becomes this u prime. And then, since we multiplied by negative 1/3, we also need to multiply by negative 3 in order to cancel this out. So I'm going to put a times negative 3 up here. And if we take these out, because of the reverse chain rule, we get that our area is going to be this -3. We start with our -3, and then we use the reverse power rule for this term. So that's going to look like 2/3 4 minus x squared to the 3/2 power from 0 to 2. And I see that this 3 and this 3 cancels out, so we're just left with that. And then from here I can just expand and we'll get our answer. So a equals -2 4 minus, plug in our 2 squared to the 3/2 power minus a negative, so we're going to be adding, plus 2 4 minus 0 squared to the 3/2 power. And now from here, we can see that 2 squared is going to be 4. 4 minus 4 is 0, so I can just cross that term off. And then we see that 0 squared is 0, so 4 to the 3/2 power is going to be the same thing as the square root of 4 cubed, which is 8. So that's going to be 2 times 8. And we get that our final area is 16. So here is our final area. Okay, moving on to part B. It tells us that it is known that for this equation, it has a dy over dx, and it is given by this equation. For a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. What is the value of c for this spinning toy? Okay, so just to take apart this problem real quickly, we can see that when it's asking us to find the radius of the largest cross-sectional circular slice, it's asking us for this point right here, right? When is this y value going to hit the maximum value? Or in other words, when is the slope of this value, when is the slope of this graph going to equal 0? So what can we do with that? Well, we have this dy over dx, and we know that dy over dx is the slope. So what we're first going to do is plug in 0 for dy over dx. So let me move this over so we can work on the right. 0 equals, and then we plug in, we just write in the dy over dx equation over root 4 minus x squared. And then we simply use algebra to solve for x. And we can see that this c actually, when we divide both sides by c, it cancels out. So we're left with 0 equals 4 minus 2x squared. 2x squared equals 4. X squared equals 2. And we get that our x value is going to be root 2. So now that we have our x value, and actually, not only do we have our x value, we actually also have our y value. So the radius of the largest cross-sectional circular slice is 1.2 inches. So we can write that our y value is also 1.2 inches. And now from here, we have our x value and we have our y value, that this is true. So now we just need to find c. And this equation will tell us what c is if we plug in our x and our y. So moving on to our next step, which I'll write in red. Right, we're using this equation right here. So what we'll do is we'll take that, y equals cx root 4 minus x squared, and I'll plug in these x and y values. So y, 1.2, equals c root 2 times root 4 minus root 2 squared. And from here, we just use algebra to find what c is. So c root 2 times root 2 squared is just 2. So 4 minus 2 is 2, so root 2 again. 1.2 equals 2c. And we get that our C value is going to be 0.6. Okay, now moving on to part C, and this one is going to be worth 4 out of the 9 points. So you'll have to do a good job of earning the most amount of points as you can for this one. So for another spinning toy, the volume is 2 pi cubic inches. What is the value of C for this spinning toy? So right here, it's asking us for our volume. So we know that for this problem, we're going to be dealing with a volumes of revolutions problem. So what I'm going to do is I'm going to set that up. Our volume is going to be equal to pi from 0 to 2. And like I said, from part A, we know that for whatever C value this is, our domain is always going to be 0 and 2. And then what's inside is going to be this function. So cx root 4 minus x squared, and we also have to take all of that and square it, right? Dx. And right here we can already see pi r squared. This is going to be the area of a circle. So moving forward, we first have to, what I'm actually going to do is take out the c, because we know that the c is going to be a constant. So if we do that, we get that pi, this is equal to pi c squared from 0 to 2, because I just squared this c and moved it out. And this x squared has to stay in the middle because we're we're integrating with respect to x. And then this term squared is just going to be whatever's inside. So 4 minus x squared dx. Okay, so from here we have our setup. And now we need to anti-differentiate. So v equals pi c squared. And for this one, I'm actually just going to multiply this out. So 4x squared minus x to the 4th dx. And then from here we can anti-differentiate. So v is going to be equal to pi c squared. This is going to be pretty big. So using the reverse power rule, we can add 1 to this exponent, then divide. So 4 over 3x to the 3rd power minus, do the same thing for this one, 1 over 4x to the, or excuse me, this would be to the 5th power, 1 over 5 to the 5th power, 1 over 5x to the 5th power from 0 to 2. Okay, and then from here, we can try and simplify all this out. And once again, we don't have a calculator, so this is going to be tedious. So first we'll deal with the 2, 4 over 3, 2 cubed, minus 1/5 2 to the 5th, minus our 0 term that we have to deal with now. And I'm just going to write 0 because we can see that over here and here we have x in both terms, and 0 is just going to cancel all of that out. So we can just end like that. Moving on, v equals pi c squared. 2 cubed is 8. So this is going to be 32 over 3 minus 2 to the 5th is 32. And this is going to be 32 over 5. And then moving forward again, v equals pi c squared, and I'm going to multiply this by 5. and multiply this by 3, then turn these into 15. So that's going to be 32 times 5 is 160, minus 32 times 3 is 96 over 15. V equals pi c squared. 160 minus 96 is 64 over 15. So here we have the most simplified volume that we can get to. And now moving all the way back up here, we're given that the volume is 2 pi cubic inches. So I'm going to change to another color to solve for our c value. So we're going to set 2 pi equal to this value that we got over here. So pi c squared, 64 over 15. Pi c squared, 64 over 15. These pi's cancel out, so we're left with 2 equals c squared, 64 over 15. And if we multiply everything by the reciprocal, so 15 over 64, these cancel out. And then over here, we're left with 15 over 32 equals c squared. And our final answer is that c is going to be root 15 over 32. Okay, so we finally finished the 3 parts for problem 3 on the 2021 exam. If you'd like to take a look at the rest of the questions, you can just go on the College Board website. They have all of the FRQs as well as the past year's FRQ as well. So if you'd like to study, that is a great place to do so. If not, then you can also take a look at parts 1 and 2, which I've posted up on the screen as well as in the description. Like always, if you have any questions, don't hesitate to email me or just leave them in the comments. I hope this video was helpful to you, and I will see you in part 4.